I'm going to go through how to write chemical formulae using something called the cross rule, which uses the principle of valency. So valency is also known as the charge. For example, everything in group 1 has a valency of +1. And the reason why that is because they all need to lose one electron to complete the outer shell. So when an atom loses electrons, it gains a positive charge. And when an atom gains electrons, it acquires a negative charge. Okay, remember atoms are neutral to begin with. So for example, if we took, say, sodium, the configuration is there's one electron in the outer shell. So when considering how many electrons are needed to complete the outer shell, the choice is either to gain 7, which would make 288, or lose 1, which would make 28. So it's energetically favorable for sodium to just lose 1 electron, which would lead it to a configuration of 2, 8. And then because sodium has lost that 1 electron, it therefore now has a 1 plus charge. So that is where the charges come from. Then for group 5, there's the crossover. So everything would be gaining 3 electrons to complete the outer shell, so it would be -3. Then for group 6, so like oxygen, for example, would be -2. Then finally, group 7, just 1 electron is needed to complete the outer shell, so that would be -1. So we use those charges then to create the chemical formulae for particular compounds using this very simple principle called the cross rule, where you simply cross the numbers of the ions involved and ignore the charges because they cancel out. So for example, say we had sodium bromide, and we know that sodium is 1+ and bromine is in group 7, so its charge is 1-. So we've got 1+ and 1-. You simply cross the numbers. The one goes to the bottom of the bromine, and then the other one goes to the bottom of the sodium. So you end up with Na1Br1, or in other words, NaBr. So that is the formula for sodium bromide. So let's take a look at some of the examples I've listed here on the left. It says instructions: using the table of ions and the cross rule, write chemical formulae for the following compounds. So I'm going to just pick some at random and then deliberately leave the other ones so you can try them yourself, and then check your answers against the mark scheme I have attached to the bottom of this video. Let's take, for example, number 4, aluminium chloride. Aluminium is 3+, and then chlorine is in group 7, so it needs to gain 1 electron to complete the outer shell, so it'll be -1. So what we do is we cross the numbers, ignore the charges because they cancel, and the formula for aluminium chloride will be Al1, so just AlCl3. You might be thinking, well, why am I allowed to ignore the charges? What's happened to the charges? Well, let's look at this one I've just done to prove why this is allowed. So aluminium is +3. So let's represent it as this +3 like circle. And then chlorine is -1. And we can see from the formula, 3 lots of chlorine are in the formula. So that would be -1, -1, and -1. So if I add all of those charges together, it comes to 0, which is correct because the overall charge for aluminium chloride is 0. It's neutral. Right, one final thing before we look at some others is you will notice in the table there are some ions which are not elements. In fact, they're called compound ions. For example, carbonate, hydroxide, sulfate. I'm going to add one that's missing, PO43-, which is known as phosphate. So these are called compound ions, and the reason why they're called compound ions is because they're made up of 2 different elements chemically bonded together. And the main thing to remember is the charge applies to the whole thing. So if I just take that phosphate and use a different color to emphasize what that means. So the phosphate has a 3- charge. So the 3- charge, it doesn't just apply to the oxygen. It doesn't just apply to the phosphorus. It applies to all of it. So you've got to remember to put brackets around the whole thing. So it would look like that. So let's put that into action and try one which has got a compound ion. So for example, number 10, calcium nitrate. So calcium is in group 2, which will be, therefore has a 2+ charge. Nitrate is not in the periodic table. It's one we just need to know because it's a compound ion, and you just need to remember the charges with compound ions. And you'll see that it's right there. It has a negative sign, which means -1. And don't forget to put the brackets in. And then we go ahead and we cross the numbers. And therefore we finish with Ca1, but we can leave the 1 out because it's just Ca. Just like in maths, you don't say 1x, you just say x. So that we have Ca and then bracket NO3 close bracket. So calcium nitrate is Ca bracket NO3 close bracket 2. So please continue with the rest of those. Check your answers against the mark scheme, what I've attached below the video. And if you have any questions whatsoever about this technique, comment down below and I will get back to you. Otherwise, I will see you in the next one.